let us learn concepts. Yeah. So I'm starting from parallelogram law of vector addition. Now, parallelogram law of vector states that if two vectors, so let's say we have two vectors like this. If two vectors, so I'm calling this vector P and I'm calling this vector Q. Now, if two vectors are represented by the two adjacent sides of a parallelogram, this is how we draw a parallelogram. So that means these two vectors here are represented by the two adjacent sides of a parallelogram in magnitude and direction, as you see the arrowhead here. Then the third side, and then the line drawn from the point of intersection of the two vectors represent their resultants. So you can see this is their resultant. Trace the definition and the parallelogram law again. Parallelogram law of vector states that if two vectors are represented by the two adjacent sides of a parallelogram, then the line drawn from the point of intersection of the two vectors represent their resultant. So that is just parallelogram law of vector. Now if we continue with this parallelogram law, I have dotted line here as in complete the parallelogram. Now for a parallelogram, this line is parallel to this line and this line is parallel to this line. Now definitely if this place is vector P, here too must be vector P, as in this line. Now if here is vector Q, then this one too must be vector Q, meaning this side and this side are equal. Also this side and this side are equal. Now if I drop a perpendicular line there and extend this line and extend this one, so let me label A, B, C, D, E. So now look at this parallelogram here. If this place is angle 90 and the angle between two vectors, I represent it as theta here. Now if this place is theta, here too must be theta. Why? If you draw a parallel lines, so for parallel lines we have corresponding angle. Corresponding angles are equal. That is, if this place is x, then this outside also will be x. And if this place is y, then this one too will be y. That is corresponding angle. So that means if these two lines, this one and this one, are parallel, then if the angle here is theta, then the angle here too is theta. So that's the meaning. So the angle there are equal. So now what is now this place? What is this place? Let me call it y. And what is this place? Let me call it x. Now from this right angle triangle here, from the right angle triangle there, we can have to find this place using SOHCAHTOA. So that will be opposites over hypotenuse. So opposite is y, hypotenuse is p. So that means sine theta is equal to opposite over hypotenuse, so vector p. So if you cross multiply, y is equals to p sine theta, like that. So if y is p sine theta, then we can have cos theta. If you switch cos theta here, that will be adjacent here over hypotenuse using Pythagoras again. So the adjacent is x. So that will be x over hypotenuse is still p. So over 1. So cross multiply again. So x is equals to p cos theta. So that means we have known x and y. So y is p sin theta, x is p cos theta. So now let me put it there now. So this place is p sin theta, while this place is p cos theta. We have proved that now. Okay, so now look at this shape very well. Can you observe a right angle triangle here? As in, which is this? Let me trace it. So can you observe a right angle triangle here, like this and like this? So you can see. So now if you look at the right angle triangle very well, there is a line that divided this way, where here is q and here is p cos theta. So definitely from here to here is q plus p cos theta. So why this place is p sin theta, and the angle here I will represent it as alpha. So that is here, I'll call it alpha. So that is the angle which the resultants make with the horizontal. So now let me go back to the okay. So based on that illustration, so total length here is q plus p cos theta, y from here to here is p sin theta. So using Pythagoras theorem, what is Pythagoras theorem? Pythagoras theorem states that hypotenuse square. So if you consider this triangle now, you will notice this is the hypotenuse. So I will represent this place as alpha. That will be the opposite, alpha. So that means this is hypotenuse r, opposite is this, while adjacent is all this. So now let's use the Pythagoras. So hypotenuse square, that is r square, equals to opposite square, that is p sin theta square, now plus adjacent square. So adjacent is q plus p cos theta. So adjacent square. Now if we solve this mathematics here, so this will becomes r square is equals to p square sin square theta plus q square. So we have to expand this one twice. That will be q plus p cos theta, another q plus p cos theta. So that means r square is equals to p square sin square theta plus, now expand this one, q times q. So that will be q square plus q times p cos theta. That will be pq cos theta plus this one times q again. That will be pq cos theta. Then plus the last one, p square cos square theta. So now r square is equals to p square sin square theta plus q square plus, now these two are equal, so that will be 2pq cos theta. That is pq cos theta plus pq cos theta. That will be 2pq cos theta. Then plus p square cos square theta. Now I'll bring these two together. So this will becomes r square equals p square sine square theta plus p square cos square theta plus q square plus 2pq cos theta. Now this will becomes r square equals, now p square is common here, so this will becomes p square into sine square theta plus cos square theta, then plus q square plus 2pq cos theta. But from trigonometric identity, all this one is 1. That is sine square theta plus cos square theta is 1. So r will be equals to p square, as in r square will be equals p square plus q square plus 2pq cos theta. So r is finally equals to square root of p square plus q square plus 2pq cos theta. Now this formula I got here is the general formula for resultant of a vector. So that is, if two vectors are acting at angle theta to each other, then their resultant is r is equals to square root of p square plus q square plus 2pq cos theta. Now from here, there are now general case and different cases we can get from here. That will be in the next video. This one is just a proof of all the formulas.